Hi and welcome. The project this video has had a DRO to this tailstock on my lathe, and it already has graduations on the handle that you can set and a scale on the shaft itself, but among other things the drill chuck accessory will be ejected from the tailstock if it's anything closer to 0 than about a ½ an inch, which means you can't even use the last ½ inch. Very odd, but it's the way it's designed. The MT4 shank is probably just a bit too long, so it ejects early. So among other things, I'd like to be able to pick any point as my 0 and go from there, which is what I've done in the past, but then you've got to try and figure a value here for 0, figure a value for here to 0. Not terribly convenient. So here's my ideas. I've purchased an inexpensive scale, 8-inch scale, to go on the back of the tailstock, and I have to make a mounting clamp. That's going to be the challenging part. So it's got to be at an angle so that this is easily readable from where I stand, so it can't just lie flat. And then my original idea was to go easy and make a mounting bracket that would fit on the shaft of the tailstock in 2 pieces, because I need a vertical part that sticks out that can catch the arm of this guy, and I also need a piece that mounts, that it can clamp on the tailstock itself. So between these two, if you tried to turn it all, it would be really problematic, because, you know, how do you get this lined up right? And it's going to take a big piece of material. So my first thought was, let's go easy and just make this piece separate from this piece. But then I have to somehow drill, tap and screw this guy on here, and I really wasn't happy with that idea, and it didn't seem overly strong. So instead, what I've decided to do is make it in one piece. So I don't actually have a drawing. Here is what it would look like attached right now. And I even think I'm going to make this mounting bracket a little bit different. This is my preliminary design. So what I'm going to do is I am going to make a part that has a whole board with the exact diameter of the tailstock shaft, which is this guy right here, and then it's going to protrude. It's going to have a lobe that protrudes that I can make a holder to catch this shaft. This will be fixed mounted on an angled base piece that I'm going to make up here. So that is my goal. Now, I've got several approaches for making this all in one piece. The easiest way is to take a piece of material that's the diameter, that with this part centered that I need to bore out, the whole part will fit within that diameter. That's a 6½ inch piece of material, and I'll be removing a ton of material. All of this would go. All of that would go all the way around except for this last part, which I think I'm going to make wider than I've got shown here. Now another solution I can have is I could mount this in the lathe off-center so that the part that I need, which is just this little round part here, and the part that sticks out, is biased down off-center so that I can fit it in a smaller piece of stock. Let's see if we can pull that off. First I got to find the smaller piece of stock. I hate to basically throw away 2/3 of the stock. It's going to be hollow in the middle. It's basically just a ½ inch segment out of this whole giant piece. Kind of crazy. So I'll bring you back when I get a little further. Also, in order to make this, I have to, again, I'm going to make a fixture. So I'm also working on fixture design. I'm kind of curious about it and want to learn a lot more. So I'm going to make a fixture in order to cut out this piece to make it one piece, because I need a straight section here and I need a bored out section. So, and I could do this all on the mill by using a boring head and boring this out, and then on the rotary table remove this section. But I decided to do it in 2 parts. So I'm not going the easy route, I'm going the interesting route. So I hope you're interested as well and want to come along with me. Alright, so to make the round compression piece right here that is going to squeeze on the rule of the digital readout, I'm going to do it the hard way. So what I want to do is I want to turn a round piece out of square stock. So first what I'm going to do is I've cleaned up the sides of this aluminum, one on each side. This is bigger than I need right now. And I'm going to take and sandwich 2 pieces of copper because I didn't have the right thickness. I want about 40 thousandths. This is 20 thousandths a sheet. I'm going to put super glue in there, sandwich these 2 guys together under this arbor press here. Well, it's not an arbor press, it's a hydraulic press. It's a really mediocre Harbor Freight one. I don't recommend getting it. It has almost no throw at all, even with this all the way down. It's very limited in its capabilities. I recommend getting something bigger. Harbor Freight sells bigger ones. If you can't afford the, a really decent one like a Dake or something like that, which I can't at this point. Anyways, I am going to super glue these guys together. So I've compressed this guy to the full 6 tons, I believe, and it's 6 tons over quite a few square inches here. I don't know, maybe I don't know, 8 or so. So it's dividing that, so it's still a fair amount of pressure, and I'm going to let these guys go until they cure, and hopefully I'll have one piece that I can mill down and then turn. So here's the result of the copper aluminum sandwich. See that line of copper there, about 40 thousandths thick. It's actually 2 sheets of copper. I squeezed these 2 pieces together with super glue and about 6 tons of force. And what I'm hoping to do is to chuck this guy in the 4-jaw chuck and turn the end round 3/4 of an inch in, about 3/4 of an inch, and then 1 inch diameter for the outside, and then part it off, and I'll be left with the pieces that I can actually put in the mill to hold it while I'm working on. So I'll heat this up after, and the super glue should release, and then I'll have 2 pieces with half circles on it, which I can take and mill the slots in for the rule of the DRO. So this is my best hope. I decided to take this approach because I thought it'd be fun and interesting, not because it was easier. I could have just taken round stock, turned 2 pieces that had the 3/4 diameter section on it, mill off half of each section, a little over half, so that they can squeeze together, and then machine those and then part those off. And I could have just done that twice and had the 2 pieces. But I thought this would be more fun and more challenging, so seems like it could be interesting. So let's see how it works out. If it doesn't work out, I'll go back to the other solution. Alright, so I got the square piece of material that's got these copper sandwich in the middle. And what you do is, to get it centered in the 4-jaw, you look for the low point, and you try and get the indicator as close to the center as you can. And again, hit the low point. So that's like a 1/2 thousandth to one side, and then you do the other side. So if I made this 0 right here, hop around, there you go. So that's like a 1/2 thousandth, because what you do on one side takes from the other side. So if I do 1/2 thousand right there, so let's re-zero this, see how that worked out. So just a little bit, now I'm like a 1/4 thousandth or maybe a little around a 1/2 thousandth. Let's see, there's the 0. Yeah, so just the tiniest bit. And this side I didn't even square up, so I don't really trust it anyways. Don't forget to pull your indicator back as you rotate, or you can damage it. Or at a minimum, you're going to screw up your setup and have to do it over. So we're centered now. So let's set this up and let's turn this guy down. It's going to be an interrupted cut, which I have concerns about because it's just super glue holding these ends together. Hopefully the 4-jaw chuckle squeezing will be enough. One thing I thought about was putting out more material than I was going to use, putting a screw through the end to hold the 2 pieces together all the way through. But I'm going to try it like this. Live and learn, right? Hopefully we'll all learn something. Alright, so we're ready to go here. I've got the speed down to 180 RPM. It's going to be a significantly interrupted cut at first, so we're just going to go slowly because all that's holding these 2 pieces together is super glue. So we got to be careful. Alrighty, let's see how this works out. So I had to stop, novice mistake. I didn't do a sanity check and use my center to make sure I was actually centered. And what I had done is my indicator was actually off by a full 100,000, a full tenth of an inch, 100,000ths of an inch in each direction. So it was processing around. I should have noticed, and I did sort of notice, and I thought that looked odd, that the center of this should have made a spinning pinwheel, but instead the center wasn't a dot, it was round by a tenth of an inch in each direction. So I have fixed that now. Novice mistake. Use your center to make a center mark in it so that you can find your center first to verify, and double check that you're on the same number on your indicator. So that was my bad, and we're going to start cutting again. Alright, so let's try cutting again. This time we should symmetrically take off of each corner the same amount. Oops, I'm in neutral. So it does look like a pinwheel now, that's a good sign. And after we do this pass, we'll go out and look to make sure we're getting all sides equally. Shame on me. Definitely a novice mistake. Okay, we're starting to touch every corner. Good sign. Obviously this one's down farther than all the rest. So we're going to keep going here. I was going to speed this up. So let's go to 300 RPM. I think we should be okay there. And we'll go in another 50 thousandths. This is a coated insert, but I don't want any aluminum sticking to it anyways. What's it looking like here? Looking good. Very nice cut too. All right. Well, let's keep going. Another 50. By the way, if I didn't explain it, the reason for the copper spacers is so that when I'm done, I'll have a 3/4 inch diameter with the center area that can squeeze together a little bit further. That's so that the two sides can press on each other. Okay, first part done. So here's our 1 inch round. You can hardly tell that interface lines there except for the color change. Very nice. So now we're going to turn down to 3/4. So let's do 50 thousandths. Let's see, we got 1/4. So see how that goes. And by the way, I could have avoided using 2 sheets of shim stock if I wanted to use some of my steel shim stock, but I didn't want the cutter to have to deal with that transition of materials. Copper is soft, very soft like aluminum, so I thought it was a better choice. So that's what I chose. A lot of sharp edges there need relieving, but let's take a look. 7485, that'll work. That'll make it just a little bit loose. We don't want it to be too tight. 488, so that's 1,000th under. So let's chamfer some edges and see if we can heat this and get these two parts to come apart safely. Alright, nicely done. So to get these guys apart, I'm going to heat them up. According to Loctite, it's technical information about their cyanoacrylate glue, and they claim they have a special additive that makes it better than others, but their working temperature is only 170 Fahrenheit or something just under 100 Celsius. That means even with a safety margin, if you heat it, well, a little bit over 200, it'll probably degrade. I don't know if the glue denatures, degrades, melts, whatever the case may be, we should be able to just release it by heating. Unfortunately, it's aluminum, so the heat should conduct pretty well. So we're just going to heat it up and see what we get. So again, if you were wondering what the copper layer was for, that's basically the gap I would have had to remove in order to sandwich the rule of the DRO in. So I figured this way I won't have to do an extra operation and mill it out because I'll have added the spacer in there. Originally I was just going to glue the two pieces of aluminum together. I thought, well, what the heck, might as well just do it all in one shot. So I've never done this before, so I'm not quite sure what to expect. Well, that was pretty easy. Oh, look at that, it just floats right off. Appears it's a little bit flammable as well. Alright, there we go. Just clean off the glue with a razor blade and I should be good to go. So I've separated this, taken the copper spacers out of the middle and cleaned this up. And now what I'm going to do is I'm going to mill out a slot on each one of these because there are going to be a clamshell around this guy. So this is going to be partially recessed into one, partially recessed in the top, and then that spacer that I took out will be the gap between them. And it should be very close, and that means when I tighten this down, it'll sit really nicely in that 3/4 hole I bored, which is this outer diameter here. So I'm going to put an 1/8 inch milling cutter on here, and we're just going to mill out the section here for each side of the clamshell. So I also want to say this will be the first time I get to try my new camera rig out that I built. I didn't show making of this because I didn't know that anyone would care, but I made this plate originally. It's an off-centered, oops, sorry, this plate here, it's an off-centered bored hole, and it's mounted into the mill itself, and then I made all the rest of this. I turned this guy, and that holds this guy and stops it from rotating. Then this long arm is somewhat flexible. So what I did was I put a large mass that I could slide out towards the end, and what that does is it allows the bar to flex, but since this is a large mass, remember, objects at rest tend to stay at rest. So hopefully if even the column of the mill vibrates, that it'll get damped out a lot in this column that I made here with the big weight on the end. It might be better on the other side of this, not quite sure. I normally was going to operate this with this guy somewhere out here and the weight out here, which makes it damped even more. So if you vibrate this, the camera itself, it'll keep vibrating because now you got a lot of mass. The camera is actually really light. But if you knock the mill column, which I did, this doesn't move much at all, and that's exactly what I want. So hopefully that'll work out just right. So it articulates every which way. This part slides along the horizontal piece. It vertically adjusts up and down, and this guy rotates back and forth. I screwed up on this piece. Actually, I was meaning to cut this end off here, but then I thought, you know what, having access from both sides, maybe I might want to move it to the back. I don't know. So I just left it for now. If I decide, I'll cut it off. But basically, that's my camera rig design. And then I've got a pin on the bottom of my camera that screws into the 1/4-20 slot in the bottom of the camera that fits in here nicely, and then I tighten it on that. So let's see how it works. Hopefully, we'll get rid of some of those vibration problems. Let's go back and machine out the little slots for this guy. Alright, so depth-wise, we're going to go down, instead of the 58 thousandths for exactly fitting the part, we're going to give a little more slop. So we're going to go down a couple thousandths extra, we're making it even 60, and then taking into account the 1/8 inch diameter, the 0.125 inch diameter of the cutter, we're going to go plus or minus 0.253, and we'll go in. I don't know, we're going to do this by appearance, but because that rule can sit in here at any point, because we're gonna null it out based on the settings on the digital readout anyways, so it's not critical. So we're going to do it by looks here. So let's get started. We're going to run this about as fast as we can go, I think, because this guy is a tiny cutter, so they like speed. And we're going in only 60 thousandths depth of cut. Hopefully for a small cutter like this, that's not a big deal. They do break really easily, solid carbide, so we'll see. So we're at 4,200 RPM here. The first pass, too delicate for that. Man, I was hand feeding very slowly. These are delicate. I'd like that small corner radius, but geez Louise. Well, I decided I don't want to fight those really delicate solid carbide 1/8 inch bits I've got. So instead, we're going to go for a 1/4 inch cutter, and we're just going to allow the radius to be large on the end because it's going to have lots of slop room anyways, so no big deal. And we're just going to go in, and we have to do less motion this way, so it'll actually be faster. We'll slow it down a little bit. Of course, got to put it in gear, right? All right. Okay. So we're going really slowly with this because we don't want to break this cutter either. But those 1/8 inch cutters, I have never been able to use them without breaking one. No matter how delicate I think I'm being, I'm not delicate enough. So this time, we're going to go with a slightly beefier cutter to make up for my clawed handedness. I'm going to go just past the center line here. I'm going to call this X0, and we're going to go over 190 thousandths. Actually, maybe what we'll do is we'll come out. We're going to come out, do 190 thousandths, so I don't have to fight full material. So here is plus 190. Coming back out, we'll go minus 190. I'm actually going 191 because I'm trying to give myself a little extra material, a little extra slop room. bit. Head over to +190. And we should be good. Let's see how the fit is. And that's a really great fit. So now the top piece, I'm going to do the same thing to the other one here. And those two will clamshell over the top of this guy and hold it in place. It's a little bit of slop. I give myself a couple thousandths aside, 2 or 3. So now I'm just going to do the same thing again. And we'll be done with this part. Well, then we have to cut off the end of this part here. I left all this extra material on so I'd have something to hold it in the vise. That was the plan. So here's the two clamshells together. There will be a screw pushing on the top of this guy as perpendicular as I can get it to this clamshell, and you can see it's nice and tight. Doesn't want to rotate at all. And that's with almost no pressure, just holding two clamshells together, or the clamshell together, not two clamshells. But in any case, you will see when this part is finally mounted. I still got to part this off and clean it up, but we're pretty much good to go on this. So when I was making the clamshells, I made another novice mistake at the very end. You can see the distortion along the edge of one of the two. And what I did was, when I put these guys in the vise face down so I could mill this side after I cut off the rectangular section. I wanted to make sure they didn't move, so I tightened the vise, and even though I was using the speed handle rather than the regular arm on the vise, there's enough torque to crush the slot I had just milled. So I had to take a file and open this up in order to get it to work again. So you got to always be very aware of where your vise is making contact. In the case of this, just 2 points on the edge here. And so there's this very thin section. Even though this is only 60 thousandths deep, it's only making contact at the very top. And so when I tightened it down, it crushed it just enough to make this not fit. So I had to get a file in there and remove some material. So just something to be aware of. So that concludes this part of the video. Next time we'll be getting on to the remaining parts, the adapter plate that goes on the quill of the tailstock, and the bracket that mounts on top of the tailstock that holds the DRO itself. I know that the approaches I took in this were not the easiest or the simplest, definitely not the most efficient, and I realized if I had a machine shop, that would not be the way to go because you'd be losing money. But I chose these approaches because I thought they'd be interesting and I'd learn something from doing it. So anyways, I hope you found it interesting as well. Thanks for watching. Hope to see you next time.